Mario once again with MIA Microflight, and this is the Coaxial helicopter, rubber-powered helicopter that I just put together. I finished these parts early this morning. Um, I was up all night doing this because I wanted to get this going and finished. So I did two types of coaxial setups here. One is using the pulleys that you see there. It's working just fine. And these are with the same pulleys that I use for my other helicopter, the that one right there. I need to wrap that rubber band. It uses that pulley and that pulley at the tail. And so I decided to use those same pulleys in this counter-rotating setup here, except that my shaft here needs to be a little bit longer just to clear the blades a little bit better, but they're working pretty good. I do need to balance the blades because one of them is a little bit off balance, and so I have to I think that became off balance when I glued the this covering here to the balsa to this balsa leading edge here. So I'm gonna have to do that at a later time, but I just wanted to capture this on video. This is one setup here, and this is the other setup here using these gears here. And I designed this gear with sort of this is a crown gear. As you can see, the spacing on that gear is quite defined there, and that was just so that I could get the pinion gear that goes horizontally on this, two of them, at opposing ends, 180 degrees, so that those pinions can drive this nice and easy. It just works a lot better, a lot more efficient when the teeth are larger than having smaller teeth. Besides, the 3D printer can only print so small with some degree of tolerance, and so making the gear this way with the larger teeth just makes for a better gear. And so this is the top or the bottom, and that's the top gear here. And this is the pinion, one of them. And to enlarge that little hole that you see there. So I'll be doing that setup. In another frame, just so that I can have both types of mechanics here. But this is working just fine. You can see here the rotor heads are also 3D printed, and I did that 3D printed instead of balsa wood like the other one, because in this case here we have almost twice the amount of lift here with these two blades here, two sets of blades. So there's quite a lift here with these blades, and they counter rotate, so they counteract the torque. There's no need for a tail rotor or a surface fin like that one there. So this one will basically just work without a tail rotor, or I am going to put some kind of a stabilizer here because it is a little bit nose heavy. I made the landing gear similar to the other ones, and it just got a little bit heavier towards the front because of also these pulleys that I inserted there, where they run through they run on a 1/32 steel wire, which is going through a brass tubing there, 1/16 1/32 ID, 1/16 OD brass tubing. This runs through 3/32 brass tubing. 116 is the shaft. You can see that runs inside that. There's a tubular shaft there. Very much in line with the drawing that I did on my first part of this video. So this is where I'm at with this. It's working out pretty good, and this should actually fly pretty nice, you know, with these two sets of rotors here. Once I get the shaft long enough, so I am going to make the shaft longer, as I said, so that I can have a better clearance here, because this is almost rubbing against each other. So we'll do that in the next video segment. Stay tuned for more.